I'm live. Okay, good. There it is. Goodness. Hi, all. Sorry it took me so long. I've got a new kind of setup. If my lighting looks a little bit different, it's because I've got a new set of lights and there's just upgrades on the studio, and it's kind of been a little troublesome getting it all going. So I apologize for the delay. How is everyone? I hope everybody's doing great. I see lots of people in the chat. Hi, Janice, Karen, James, good to see you. Thanks, Mike, for being here. I appreciate that very much. Everybody be very nice to Mike Richardson. He is one of our moderators and a VIP of my Patreon community. And Jerry is here too. Thank you so much, Jerry. I appreciate it. Yes, Tamitha will be here shortly. I know. As a matter of fact, let me grab my phone. If I have trouble, those who have my phone number can get a hold of me. Yeah. Whew. Okay, goodness. Hopefully everybody's having a, my phone's going nuts now. Hopefully everybody is having a good time and had eyes on the sun. It's been a lot of fun. I was expecting a lot more from the sun than it's given us, sadly. And we'll get into that today. We'll talk a little bit about where we think it's going. I don't know if you know this, but there have been actually 4 different active flare players, big flare players. The big bulk of them that you see behind me, this grouping right here, which we'll talk about in a minute, is not the only ones. We actually had a disconnected one that's now rotated to the sun's far side that looks like it's beginning to wreak havoc back there too, and we'll talk about that region in a second. But we have no Earth-directed solar storms, so aurora photographers, you know, it's been quite surprising, actually. We had a few big eruptions, and this is something that happens very often on the sun, is that when you get a few really large eruptions that we did have on the far side from these regions, it kind of spins that whole area above the region that's flaring. And what ends up happening is that you end up not having any big solar storms being launched. And they end up oftentimes going off on one side or another instead of straight outward. And we'll talk about that in a minute. These regions have had some solar storms being launched. Don't get me wrong. There's not been none. There's just not been any that are Earth directed. They've kind of gone off in interesting directions, and a couple of them are not normal. They're kind of atypical. And I think part of that is to do with the fact that there were some really large solar storm launches on the sun's far side prior to them even rotating into view. Hello, everybody. Oh my gosh, I see so many wonderful people from Patreon, as well as my YouTube family. So thank you guys. Hello. And it sounds like everybody can see me and hear me. Good time for being sick. Oh, Lisa, please. I hope you're not still sick. Yeah, well, I guess it is a good time. If you have to be sick, it's a good time to be sick now if you can't chase aurora. So that's a good thing. Okay, so let me get started. I'll have some fun stuff to show you, and I'll show you some good news and some bad news. Depends upon your point of view, who you are, if you're an aurora photographer or if you're a ham radio operator. I'm sure you guys have known that the bands are not too great right now. We're dealing with, of course, a very large region on the sun that is actually comprised of multiple regions, and we'll talk about that. Let me let it reset. There is reasonably this group here. You can see we're flaring on the sun's far side before they even rotated into view. Let me go ahead and rewind this. These regions here that you're seeing, this was region 29, back and forth, 2994 right here. This one right here, which flared prior to it, is 2993. This region actually ended up being a new region. This region was one that we had seen before. This was a big flare player, I think 2975. From the rotation prior to this. So about 27 days, about 20 plus days ago, this region was firing as region 2975 here on this side of the disk. And it managed to survive the far side passage, and it managed to kind of help string along a new one. So both of these regions ended up being big flare players. As you can see, we had numerous, and we'll talk a little bit more about how many big flares there have been, but numerous X flares as well as M flares. And then once these two came fully into view, and I'm sorry you can't tell the difference between them right now, they just look like one big mess on this wavelength, but we'll break them apart and break them down here in a minute. You'll be able to see the difference. But you have these two regions here, and then back here is another region. This region was labeled 2995, And this region is also a return player. This one was not, I don't think this was region 2976. And this region was not a massive flare player. If I recall the last time around, it was kind of a synergist with this region. They kind of like worked in tandem, but it was always this region that was flaring, doing most of the flaring. And sure enough, same thing around this time. If I play this again, you'll see most of the activity comes from these two regions here. This region here, no, that's not really much. And we really haven't seen much come from it. Although we now have new regions that have been rotating into Earth view. We have region 2996, which I believe is this guy right here. And well, we're going to have a few more. This is going to be labeled next. There's one more that's rotating from the south. This is also one, and we'll talk about it in a little bit. This one that's going to be rotating into Earth view is also a return player. Are we going to see big flares from it? It's hard to tell as of yet, and you'll see why in a minute. But I doubt it. I don't think it's going to be that big a deal. The big surprise that most people probably, unless you were paying attention to the sun, was region 2990 over here. See that? Boom, boom, boom. Okay, boom. We actually got several massive flares from this region, and I'll show you, including solar storms. But once again, when you get stuff firing on the east limb and firing on the west limb, where's Earth? The sun is firing to the east and to the west of us, but not firing anything Earth directed. So we ended up not getting a solar storm that's been Earth directed, despite the fact that we've had a ton of big flares over the course of this past week. Now, sadly, how many of you, raise your hand, how many of you have actually seen Armageddon and people calling for the end of the world and the kill shot and all of this stuff? Has anybody been inundated as I have been? Because I had a lot of people tell me, "Oh my gosh, I'm so scared. It's so bad. How can you be excited about these flares? This is awful. We're all going to die." It's unbelievable to me how often that happens. Every cycle I see, yes, raising both hands. You know. Right. Lisa, Tamitha, we've had 12 Carrington events this week. I know. Isn't it amazing how we're all dead? Didn't you realize that this is what a ghost feels like, right? This is somebody pinched me. We've all have to be dead. We have to have been wrecked, wiped off the face of this flat earth 20 million times over, right? Because these Carrington events just keep coming. Yeah, sure it does. Yeah, so you see this. You guys have seen it too. It's so bad. It's unbelievable. So when people come at me on my channel or anywhere else and they say, "How can you be so cavalier? There's X flares. Oh my goodness, these have the X factor." I go, because it's fun. Most of the time, right? 99.9% of the time, it's just paparazzi bulbs. And there's a lot of fun. And potentially we could get aurora, and maybe amateur radio operators groan and pilots groan, right? Believe it or not, we actually have space weather warnings for aviation. It's because of the radio bursts and the not so much the radio bursts, but the big radio blackouts that we've been having, especially over the poles. So it's nice to see the aviation world wake up a little bit, commercial aviation. It's nice to see space weather making headlines, but not once should it have ever been doom and gloom. Not once, right? And it's not going to be that way even moving forward. So those of you who are concerned about it, don't be. Please just relax, enjoy space weather, and you're going to be fine. Sounds like you're laughing at Christians. No, I'm not. I'm laughing at people who are, I'm kidding, my family are Christians. I'm not laughing at Christians. I'm laughing at people who think who believe all the hype on YouTube that our sun, by producing X flares, which it's done for longer than Christ has been, lived and died, that means it's the end of the world. I'm not laughing at Christians, not at all. Most Christians don't act like every time the sun has an X flare, it's going to be, Armageddon. That's not the way it works. So thousands, if not millions of X flares. Yes, it's too funny. Anyway, so hopefully those of you who enjoy looking at other space weather channels, if they invoke the kill shot, or if they say, "Oh my goodness, housings are going to burn and dogs and cats are going to rain from the skies," just enjoy the entertainment, right? Don't take it to heart. Don't be too concerned, because to be honest, this is just normal business. This is just our sun waking up, beginning to realize that it needs to, kind of shed some energy, right? That's what it does as that dipole field begins to collapse and flip over to the other side. It gets magnetically confused, right? It's having a bad hair day. I mean, however you want to explain it, but it really is nothing more than this. Our sun is a middle-aged star. It is a very well-behaved star. We understand the magnitude of its emanations, if you want to call it that. We understand that stuff very, very well at this point. It's not going to go supernova or micronova or microflare or kill shot. It's not going to do something like that. And the chance, especially on the ascending phase, the chances of us getting, super extreme events, well, it's rising, but we'll ride through them. That's the whole point of this community, right? Is that we see what the sun is doing and we ride through whatever is going to come to us, and we do it in a smart way without getting too riled up about it. Okay, so let me get off my soapbox here and go to, let's go to the red sun. And the only reason why I'm going to show you this is just because there have been some really, whoops, hopefully you can see that. There has been some really nice, sometimes if they show it, I'll show some really, really cool difference images. There have been some really energetic eruptions. But if you notice, a lot of this stuff is, a lot of these small flares are not having these massive amounts of plasma, massive amounts of material being launched, unlike that. Okay, so you saw that one there. That was a beautiful one. And I probably have a good movie of that on my Twitter feed, actually. Those of you who saw the tomorrow forecast or on my Patreon community, where is that stupid thing, know very well what that was like, because I had a really high, is that the one, or is it one after this? Come on. No, I guess it was what, I just can't control this thing well enough. Yeah, I can't control it to see that frame. My Macintosh has not been behaving well. Anyway, we had a lot of big ejecta going off onto the east side. And since then, you can see some jets kind of going up this way, up to the north, but there really hasn't been a lot. I've been paying attention really close to this filament here, because that's a core filament. Do you see that other one? That was a big X flare as well. With the X flare was attached to that material. I got to be careful how I say that. The X flare was not the CME that got launched. Let me go back to that event if I can, right there. Man, can you see that? I'll just have to rock back and forth. You can see this, right? Where it goes boof, right there. See that boof back and forth? Hopefully you can see that. There, maybe if I'm afraid to let go. If I let go, it's going to probably move to a different frame. But that big this part of this ejecta, this was during that X class, one of the X class flares, but it's not the X class flare. The CME is different, right? The big eruption is different than the actual flaring itself. But again, this is not a classic structure. I mean, when we see these things coming off the sun, they're no longer that classic structure that we've seen. They're no longer as wide. And they haven't been giving us these big global eruptions. The one that actually surprised us that did that was actually region 2990 right here. And I'll show you some really nice videos that Helioseismology put together of the difference images, so you can see how much more eruptive they were. Meanwhile, this little filament right here, this core filament, I'm still watching it. These core filaments, when they launch, if this thing happens to really erupt, and I've seen it erupt a little bit, but not like totally. And here's another one. Here's a very thick filament in here. When those filaments erupt and actually eject a lot of material, that material has a tendency to be very dense, and it has a tendency to be extremely high magnetic strength, high magnetic field strength. So I'm watching for those, because those can indicate a bit more intense solar storm launch than some of this other stuff. But overall, nah, not really seen anything. So it's been a little, I don't want to call it a nothing burger, because the amateur radio bands have been hating life. But overall, we really just haven't seen all that much going on, at least as far as storms are concerned. Okay, switching to HMI. This is why we've had so much activity. Look at this. You've actually got two sets of regions here and here. This is region 2994, Earth 93. This spread out thing is region 2994. Here is region 2995. Here, this is 2996 if you're counting. And then at the very end of this movie, you'll see some stuff coming into play. That is going to be 2990, probably 2997. We'll see. At any rate, early on this set of regions, and I'll show you all the electrical activity that you can see all the discharges going off in a different view. I'll show it to you. But early on we had a lot of very complex magnetic field. For those of you who are not familiar with this kind of plot, this is an HMI. This is the magnetic imager aboard SDO. And the colors basically represent different polarities of magnetic field, either going out or coming in to the sun. Okay, so it's only looking at the radio field in and out. But what makes it important is that you do not want colors, totally different colors, anywhere close to one another. So red and blue are essentially opposite, and red fades to yellow, right? Then to green, green fades into blue, and that's the other extreme. So if you see anything like red and blue coming close to touching one another, like you can see some early on, you could see some decent regions and decent spots in there. That is, let me pull up here. That is a more dangerous or active configuration. And here is some of that, right? You see it right in here. That's probably right when that blue spot was really beginning to develop. We had some issues in here. We had some blue and red mixing in here, right? And that was part of the reason we had some very tight stuff, some entry of red into this penumbra here. So that was part of why we were seeing a lot of flaring from these regions just a few days ago. But as I play this movie and get it closer to here, I'll just fast forward it to the end here. Let me pull this back down. I know this is a little bit blurry, guys, but what's happened is that things have spread. That whole region that we saw that was blue has kind of disappeared. It's died out. It's kind of, it's been, that flux has been ejected. And this region has gotten, as you notice, it's not quite as deep red. So it's kind of, it's kind of dying out, right? So we are seeing kind of the death knell or the death throes of these regions. That's why I think you're going to see over the course of the next couple days, NOAA is really going to quiet down on its X-flare potential. Right now, and I'll show you my 5-day outlooks in a bit. Right now, we're still sitting at about 15% chance of X-class flares. I don't think so. I mean, looking at this, it really doesn't look like it's going to be any issue. This is looking pretty boring in and of itself. Not seeing any activity really from any of these. I really do think that if we get any more R1s, meaning a low M-class flare, okay, maybe. But unless we see some new emerging flux, which we're really not seeing a lot of, there was a little bit. Where did I see that? Let me play it again. I saw a little bit of emerging flux somewhere. Let me zoom in. I saw a little bit of emerging flux somewhere in the back part of this, which I'll let it rotate around, but I saw something coming in here, but it really was, it looked pretty minor. Lift this up a little. But so you can see that region there, that kind of dying out, really not doing much, you're losing it. And then there's something growing, I think, in here at the very end. Where is that? Oh, right in here now? Yeah, something like that. But, I mean, it's just, I'm not seeing much flux emergence. Things are really beginning to spread out as sunspots have a tendency to do. So it looks like the worst is over. If you're an amateur radio operator and you're working the day side, if you haven't yet heard the noise on the bands go down and your SNR go up yet, trust me, you will. Over the next couple days, I really think that you will. We are not, even though the solar flux is going to continue to be high because we have that new region rotating into view, these regions here are really dying out. Now, that one, of course, is still a big player on the sun's far side, and I'll talk about that in a sec. And we'll see whether or not that one rotates around in full view. But as far as these regions are concerned, this may be it. So in other words, as this cluster now rotates to the sun's far side, it may continue to die. We'll see. one of the big tells will be, is this region, remember this region started getting big and growing right when it got to this side. And a lot of times when you go straight up in longitude, right, in a single longitude on the sun, that means there may be some stuff going on underneath the surface here that might activate. So as this set of regions rotates to the west limb, once it gets to around here, we'll see if it begins to build again. If activity begins to build again, just like you saw region 2990 get really busy as it rotated to the sun's west limb, then we'll know that there's still something left in this set of regions. But right now, I'm not holding my breath. Okay. Now, what did I want to show? Do I want to show that yet? Let me do this. Oh, poop! I don't have that. Hold on. I don't want to show that. Let me show this. Let me get this organized for you guys. Hold on. Let me zoom in. I want to show you the electrical activity of this region. And let me take off potential force free. Now, if I track, and zoom it back. Okay, so this is that set of regions. This is region 2993. This is region 2994. And what this particular wavelength is really good for is to see all of the electrical, activity, all the magnetic and electric field, lightning bolts essentially is what I'm going to be showing you, which kind of shows you where things are doing their reconfiguration, basically where things are most magnetically unstable. So what's good to see here is not just how active it is, or not just where the activity is, but also how active it is. And you'll watch it and you'll see all the little lightning bolts kind of begin to die down. But you can see where that is. And what I've done also is that in this case, I've frozen the image of the sun. See, I can actually rotate the sun anywhere I want. So we're getting kind of more of a head-on view, even though this is actually from the east limb. It's smeared out because this is the edge of our view. And so it's a mathematical interpretation of what the edge of the limb would look like. But I wanted to do this because as this region rotates more into view, you'll see this resolve better and all this blurriness goes away. And then this edge rotates further off. So it's like we're just kind of like pretending that we're sitting on the east limb of the sun looking at those regions, when in actuality our real view is really from Earth. And this is just the best interpretation we can make mathematically. Okay, so anyway, what helps is that it shows you all the activity you're seeing. Do you see? Maybe I should adjust I'll sharpen it a little. And let me try to change the levels a little. So you can see, maybe I'll slow this down too. Not 20 frames a second. And now, of course, the thing is I'm not what I should be doing. Hopefully that looks good. Yeah. I'm showing you the evolution from the 17th on. And so what you see, I'm skipping through a lot, but what you see is that early on, there's a lot of activity. And then look, as time goes on, see kind of how it's gotten quiet. So boom, 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 it's all over the place, right? And I could freeze in a few places so that you could see it frame by frame. But then as time goes on, I wish I had a timestamp here that worked. It freezes at a particular time that's located on the disk. Yeah, and I want to keep it on this angle. I could make the timestamp work again. I just have to not track the sunspot. So you can see there's a lot of activity, especially in region 2993 going in early on. See all that? We have a few really big ones going off. And then there's a lot of activity in region 2994 early on as well. Now, over the past couple days, things have really quieted down. Things have, I don't know if I really, so if I go way back, so the very beginning, so this is the 17th, you can see huge activity, okay, both between 2993 and 94, and then also just across in the entire thing. It's because we had a lot of magnetic mixing. And as time goes on, you can see a lot of activity still down in region 2994. But yeah, right here. Where'd it go? There's some right there. Even seeing a little bit of activity in region 2995 as it's rotating into view, but not very much. This is an M flare player, but just barely. But you can see there's still a lot of activity. This was about by the 18th. What is the date here? No, that's the 19th. So this is early on the 19th. We're still seeing a lot of activity. But as you notice, things do begin to calm down as we get to, here's the 20th. Okay, seeing a little bit of activity in region 2996, because that's a new region that was just growing. But see, all of this stuff is quieted down so much. So you're still seeing a little activity, but notice it's more dispersed. And so there's like one M flare there, right there. But then after that, you know, it's just kind of petering out. And I think that's really what's happening. So now we're in the 22nd. And you can see, look at this, very nothing going on, guys. So this is why I say the regions are close to dead. Okay, I really wouldn't be worrying about them anymore. I do think we've seen the end of the X flares and possibly even the end of M flares for now. Okay, I'm going to go out on a limb and say that. If we see any more M flares, it'll be maybe, you know, one or two, but they'll be probably very low. Unless of course, things can change. We could get suddenly this huge emerging flux coming from underneath, and then all bets are off, of course. But what I think is that unless we see stuff, I'll go ahead and reset the camera. Unless we see stuff on the stuff happening on the west limb, when these regions rotate into the west limb, I really doubt that we're going to be having any issues. So I'll just put this stuff together here. I'll confuse you to all get out by putting the potential field model on. Boy, I need to slow that down more. It's too fast. Okay. So here's kind of putting the whole picture together. You do know that we have a coronal hole that's right in this region. You can see region 29, 94, and 93. And then they've got a nice little potential source field model on there, and I'll show you why I have that on in a second. But you could see even region 29, as soon as it resets, you can see region 2990. Come on, reset. And reset. There we go. Region 2990 as it rotated off of the sun's west limb. That was the surprise X player. Really wasn't expecting it to be a big flare player. Now, one of the things I want you to realize, if you are a aurora photographer, I'm going to slow it down even more, and I'm going to take off this so we can look at, let's look at some coronal holes, shall we? Okay. So here is the sun essentially right now, and we do have a coronal hole that is rotating into the Earth strike zone here. It's kind of there now. It's a bit of a remnant hole. If I were to show you another wavelength 193, you'd see that this hole is reasonably closing up. The other thing, so don't expect much in the way. We've already gotten active conditions right now on the sun. Don't expect much more than that, though, because the boundaries of this coronal hole have been really fuzzy, and that always causes wind to rise up slowly, fast wind to ramp up slowly, which means it kind of softens the blow at Earth. So we're not getting much of that strong impact from fast solar wind that we can often get. And if you notice, see these color, this is the whole reason why I have the potential field on here. These colors are red. That means that we've got, this is a positive polarity coronal hole. And sadly, that means that the field direction that is coming out is probably not going to be all that conducive to solar storms right now. So it's going to weaken the field. If anything, it's going to make most of the field, I want to say weaken. It's going to weaken the potential for southward directed magnetic field. Most likely, the bulk of the magnetic field coming from this structure is going to end up causing the fast wind to have a northward pointing magnetic field. We're getting a little bit away from equinox, so it's not quite as strong a coupling, but nonetheless, you don't expect nearly the intensity of fast solar wind to cause a solar storm at Earth because of the polarity of this particular coronal hole. The nice thing is that changes once we have, in about, I don't know, 6-7 days maybe, If I can get this other hole to rotate into view, come on, he's right here. I can't see him yet, but he's right here. See all the blue? The blue lines are indicating that this is actually a negative polarity, which means the magnetic field goes into the sun. And when that gets dragged out to Earth, that direction actually couples really well in terms of making a southward magnetic field for Earth. So the chances of us having a little bit stronger, let me stop this. The chances of us having a slightly stronger solar storm from this region that's rotating, that will take probably 7 days, I would say, to rotate into Earth view or into the Earth strike zone, maybe a little bit less. That'll be better. So aurora photographers, just hang in there. You know, even if these regions are going to continue to let us down because it just doesn't look like they're solar storm producers anymore, you have a little bit of a chance. Probably only high latitudes though, and I apologize for that. I wish I could get the sun to give us something a little bit more intense, but I'm not quite sure how intense this is going to be. We'll have to wait until it rotates mid-disk to see how well formed it is. But this is right now looking like the best opportunity for Earth-directed solar storms. Okay. I'm going to minimize this for now and go back to here, because what I wanted to show you is part of the reason why we're so upset. So do I want to show that? No, let me show this one first. So here's an example. Helioseismology, if you ever follow Nariaki Nita, he's just wonderful. He makes these. He's a team member of the AIA instrument aboard SDO, and he makes these wonderful. I probably should rise it. I was trying to put a little bit of his tweet in here, but I also want you to be able to see what this looks like. So this was one of the big flares. Was this the X-class flare? This was the M96, almost an X-class flare. This was from region 2993. Okay, well, I think maybe the only one that came from 2993 that was an X-class, or almost X-class. It's a great eruption, but you're not seeing, but you notice the blast wave is kind of going out. You're not seeing a blast wave coming toward this direction, toward central meridian. It also doesn't look like there's a lot of material ejected. It makes a nice show of things, but it's not going to be Earth directed. And you see lots of little trailing material coming off. It's just not, as far as an X-class flare, it's kind of dull, sadly. And then you can see region 2992 at the same time was also letting off big solar flares. So that was one. Oh my goodness, it would be great if it were Earth directed, but not quite. Here's another one. This is more classic of a typical, what we would expect from an X-class flare. Look at this thing. I mean, do you see this? So this is region 2990 as it's rotating off of the sun's west limb in the south. This is where one of the big X flares came from. And look at that blast wave. I mean, you're only seeing half of it, right? Because the thing blasted this way. So imagine on the far side of the sun, you see an equally large blast wave. So if this had been in the middle of Earth, we would have seen this blast wave covering probably the entire Earth-facing disk. So this is more like what we'd expect for a nice flare player. And sadly, this region's now, it's left us for a while. So we don't get any more fun fireworks from it. If you're on the radio bands over the last couple days and you notice an improvement, that's because this region disappeared. Okay, because this region got very, very noisy and obviously became a big flare player, really like almost, I don't want to say overnight, but very surprisingly quickly. And then, as a matter of fact, here's one more event from it. So this event was, when was this? What was the date? 170. Come on, you're not showing me the date. You're showing me the time. This is the one that was at 4 in the morning, 3 to 4 in the morning. On what day? Oh, here we go. The 20th. Sorry about that. So this was the X2.2 on the 20th was due to this region here. And then there was another one. This one was, this was this, no, I guess this was once again, this is also on the 20th at 102. And this one was the M7.2. There have been so many. So this was the M7.2. So this was the, oh, that's right. This was the near X-class flare. And then it fired one just a little while later that was also, almost a little bit larger. But as again, you can see, massive blast wave Okay, so this one is still launching big solar storms, more of the classic view that we're used to seeing with solar storms, but nowhere near Earth, the Earth strike zone. So beautiful eye candy, lots of noise on the radio bands, zero potential for aurora. As these things go sometimes. So that's really what we've been dealing with there. Okay, I've gotten those. And if I go to just the last 7 days, you can see we've got 2 X flares on the menu. Whoops, sorry. 2 X flares on the menu, one on the 17th, and then again on the 20th, and then a near X flare here on the 21st. I mean, and if you count how many X flare or how many M class flares, because here is the M flare level right here. Has anyone counted? I haven't counted. I think we've got something. The 17th, I don't even think was at the very beginning of all of them. I think we had 1 or 2 prior that are off screen here, that are off this side. And I'll show you a great place to go if you want to get good archival data for X-ray flux and stuff like that, and just a good indicator of what these flares are doing, or what these sunspots are doing. I'll show you a really nice resource here in a sec. But as you can see, I mean, my goodness, I mean, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, just on this screen. 14 M flare, at least M flare level and above. So goodness, that's insane. And just so you know, we have been sitting kind of almost at the M flare level. When this thing got really, really intense, our background X-ray flux was getting, at a C5, C6 level. I mean, it was pretty intense. Now we finally, as of today, have dropped just below the seafloor. So finally, that noise should be going down. Finally, we should be able to you should be able to use your lower frequency bands on Earth's day side with little trouble. And that signal to noise ratio should really be getting better and better. Now, for those of you who want to know, and it's not very often that I promote websites, but there's an archive that is just so amazing. Space Weather Live, if you haven't used them ever before, they're a fantastic resource. Not just for their live, not just for their now time stuff, but especially for their archival stuff and the way that they make this kind of data available. And it's a very, very comprehensive site. So if you've never used it, it's definitely worth giving a look-see. And if you look into their Aurora and Solar Activity Archive, what's nice is that they literally have, and they've taken a lot of time to do this, they have a calendar. And so on this calendar, if you were to click any of these days, you then can not only see the largest of the eruptive flares that occurred, but you can also get readouts of the X-ray flux and everything else. So if I were to go, for instance, to the 17th, and if I wanted to look at anything from that day, the activity reports from NOAA, the sunspot regions, KP values, solar flares, it's amazing. I'll just go to sunspot regions for now, because they give a really nice breakdown of what was on the disk at the time. And then, was I calling it 2990? I'm sorry, my fault. It was 2991. Not 2990. I thought it was, no, it was 2992. My fault. What did I call it? Did I call it 2992 or did I call it 2990? If I called it 2990, I apologize. But it's really nice because you can look at all these different things. Now, SolarHam also has something like this, but SolarHam doesn't keep these nearly as well over time. So it's kind of, this has always been a really nice site. And I think if I go, it's only a little bit difficult to navigate sometimes, because what I want to find, yeah, this is what is really nice in times like this, is that you can go back and look at not only what solar flares occurred, but you can go back previous days forward and really get some decent listings of and statistics of what solar flares have been doing. So it's always kind of nice. So if anyone wants to go back and take a look, see which regions did what and how many flares there have been over this past week from these regions, it's pretty impressive. All right. So I'm almost done. I just wanted to give you a quick overview of what our KP indices have been doing. Just look at this line here. Absolutely nothing. Boring. Unless you are at high latitudes, you can been getting on and off shows. Probably not a lot of aurora that has been super, super bright, competing with the moon, but a little bit of something. We haven't had much in the way of fast solar wind either. Our fast solar wind streams have been pretty weak, but we did get a little bit of a bump up to active conditions today, but that's probably it. And if I go to the 5-day outlook, you're not going to see much more than that. So at high latitudes, NOAA we really are expecting unsettled conditions all for the rest of this week. We have up to about a 30% chance of a major storm. NOAA's giving you that big spread simply because when we look at the recurrence, this particular fast wind stream last time was a bit more geoeffective. This time it looks like the hole is closing, and so I'll bet you that's part of the reason for the big spread and just saying unsettled conditions are what we expect. But if things look more like they were last time, we could get a 30% chance of a major storm. I do think that it's going to be more on the unsettled side, and things are going to calm down pretty quickly. And then we might start feeling an effect of the next fast solar wind stream at high latitudes as early as the 28th. I think that's probably a little bit early. It's probably not going to be till the 29th, but I left it at what the NLO model was beginning to depict. So we've got about a 20% chance of active conditions as we move into the late next week, and then that will pick up quite a bit more as we even move into the weekend next week. Now, at mid-latitudes, really only about 20% chance of active conditions right now, even though you just saw active conditions. Don't get super excited, aurora photographers. Probably just sit this out if you're at mid-latitudes. Things will continue to quiet down, I would expect, over the next couple days, assuming that those regions on the Earth-facing disk are going to continue to settle down themselves and get to be pretty flare quiet. Obviously, things can change in a heartbeat. And then as we begin to ramp up, again, moving into the weekend, next weekend, we could probably see a potential for solar storm, but it likely won't be until Saturday or Sunday that we start really feeling the effect of that that fast wind from that other coronal hole that looks like it's better formed, and it has the right magnetic polarity to give us a little bit more of an oomph boost for aurora show. And now for a solar flare and particle radiation storm outlook over the coming week. Yes, I still have it at 50% because that's what NOAA has. They've lowered their X-class potential down to 15% over the next few days. I think you're going to see this precipitously drop. I mean, I'm being very conservative by dropping down only a few percents, a small amount here. I do think that they'll drop it down. The one thing they may not drop, and I'll get more to that in a second, is the risk for radiation storms, and I'll talk about that, why that is in a minute. But here are the active flare players on the disk right now, and again, it's really these two that are the big big flare potential. I just don't think if we see maybe one or two more M-class flares, I think those regions will be pretty spent. The nice thing is that solar flux is going to stay in the 160s. Even though these sets of regions are dying down, they're still going to emit a lot of solar flux. Plus, we have that new region that's going to be rotating into Earth view. That's what I forgot to show. I forgot to show stereo. I'll show you that in a sec. We will have a new region that's rotating into view, and it doesn't look like it's super flare active, but it does look bright. So I do believe it's going to keep that solar flux boosted into the 160s. Okay, maybe down to low 160s, but probably. And then, so that's good for amateur radio operators. You guys can have some decent radio propagation on the day side that will then also, give you some nice propagation on the night side as well. GPS users aren't liking this very much, especially if you're at low latitudes. Yes, that means low latitude GPS is not going to be fun because our solar flux is really beginning to grow. And that always makes those equatorial anomalies that much more intense. So just be aware you're going to be dealing with, potentially right after dawn, right before dawn and right after dusk, you're going to be dealing with some unstable, potential GPS reception. And so be very careful in those regions if you're at low latitudes. And then for radiation storms, the reason why the risk is likely going to rise just a little bit is because as region 29, 93, 94, 95 rotate to the sun's west limb, risk for radiation storms always goes up. Okay, so as long as they're continuing to be flare players, big flare players, you'll see this risk rise just a little bit. Again, likely not a problem, if for no other reason than as the chances for X-class flares dies down, so does the risk for radiation storms, even when the regions rotate to the sun's west limb. Okay, so don't get too concerned, but you will likely see that even with NOAA, you'll see that flare risk rise up a little bit. Okay, and then I'm going to show you stereo. Oh, I also forgot to show you a couple things. So let me show you stereo really fast. Yeah, I probably could have shown a few more days. Let it reset here. So this is stereo A, and it's looking at our sun just a little bit from the side, as you've heard me say a million times before. Here's regions 29, 93, and 94. Here's region 29, 95. 96 is one of these. I forget which one. Maybe this guy? I forget. And then look at this out here. See this? This is the region that is not in view yet at Earth. Well, this bit of it kind of is, but this is not. And so we're beginning to kind of see that as it's rotating into Earth view, and we're getting an edge-on view of the magnetic complexity. And although it doesn't look simple, it doesn't look like it's these guys, anything like what these guys were when it rotated into view. Plus, as we look at the activity on the sun's far side, I do see that was a small storm that was launched right there. But outside of that, not seeing all that much activity from this region. So see, that's all the active flare stuff from a few days ago. Here, yeah, I saw a little something jump off there, but it's just kind of quiescent. So I'm not sure this right there. That was one solar storm that launched, and that was recent because that was a few hours ago. So it is still a solar storm producer, but it just doesn't look as forceful or as crazy as these guys. So don't expect it to be totally quiescent, but I'm not really sure how exciting it's going to be. Do I think the risk for M flares will disappear with this region? No, I do think that there'll be a risk for M flares. I just don't think it's going to be nearly the extent that you saw with these guys. Okay, so this is why the solar flux will continue to stay up easily over this next week, because of the added the boost from this region, even as these regions begin to die. Okay, and then it does look like we even have something in the north. Don't know how big it is. We'll see. Then there's one other thing I wanted to show you. Wait, I have it here. So some of you guys noticed that, with stereo not being workable on the sun's far side, what we end up doing is because it's not viewable on the sun's far side anymore, what we end up doing is that we end up having using helioseismology to be able to give us a better view of what's going on the far side, since we don't have eyes on anymore as stereo's rotating back to Earth view. So we use HMI, and in the front side, which is the gray stuff, that's the stuff you've seen before. It was like the colored maps I showed. Yeah. Now the gold stuff is helioseismology. So what we're doing is we're sounding the sun, trying to get it to ring like a bell, or paying attention to how it rings like a bell, to be able to see where active regions might actually be. They come up as shadows that we can't really see through. And so as you see, as it comes to the sun's far side, or Earth side, and we get the view, we actually see those regions show up. And then when you go to the far side, which is everything in yellow, they show up as shadows. Okay, so the reason why I'm having this here is not so much that you can see these regions. These are the regions that we've been paying attention to, but rather to take a look at region 2992. That's this one. Okay, now we're going to the sun's far side. Look at that. It looks like it's actually, if anything, it's actually building. So I'll wait for it. It's resetting. So this is the 8th, 9th, 10th. Not super high resolution, but when it shows 2992, where are you? Here? Yeah, here. This region, this was the one that's X flare, right? Did several X flare, near X flare, and a high M class flare. It was doing a couple really nice, eruptions before it left and rotated to the sun's far side. I think we need to pay attention to this region. See how, look at all the reconfiguration was going on here. See how cleaned up? And then suddenly this thing began to intensify and looky intensifying. Okay. So I'm going to be keeping an eye on region 2992. We've got about 2 weeks, maybe about 10 days now, 12 days before it rotates back into view on the sun's east limb. I'm going to be paying attention to it all the way across the back side or the far side of the disk to see whether or not it's going to intensify. Because right now we're beginning to see that we're having these regions that are surviving. Okay, about a year ago we didn't have that because the activity was too weak. Now we're getting regions that are strong enough to survive their far side passage and come back to Earth's side and wreak havoc. So that's why I'm going to be paying attention to this region. I think it's time that we make that transition as space weather forecasters, right? To start looking at the sun's far side, even though we don't have stereo. So could be lots of fun ahead. We got a region that's rotating into view, which might be a light M-flare light player. And it could be a solar storm producer. So we've got the chances for that. We've got that fast solar wind stream coming here in about a week. And we've got at least one flare player on the sun's far, an X-flare player on the sun's far side now that may be intensifying. So we'll watch it. We'll watch it for big flares and big solar storms. Oh yeah. And while that region is on the sun's far side, if it launches a big solar storm in coronagraphs, it's going to look like it's something coming toward Earth. So for all of those crazy YouTubers out there who get space weather wrong because everything they see coming off of the sun they think is Earth directed, just be aware we may have a few really large eruptions over this next week that will look like they're Earth directed, and they're not. They're heading to the sun's far side. Okay, so take everything you see with the other channels with a grain of salt, because there's nothing in Earth view right now that looks like a planet killer. Okay, and with that, I'll go back to my 5 days. Whoop, I don't meant to share. No, that's not what I meant. I meant to just do this. Okay, so questions? Questions, comments? Oh, goodness. Moscow is on fire as well. Ouch, ouch, ouch. I don't know what you guys are talking about. Not due to the sun, thank goodness. Thank you, Grooving Goddess. You're my favorite forecaster. You're so welcome. Your windiest days are when flares happen. I have no idea. I would think, I mean, solar flares do affect the upper ionosphere, but that they're so transient that I wouldn't think that they would be able to affect the neutral atmosphere to that degree. The coupling mechanisms are just not well known, so that'd be really challenging to get it down to a local kind of thing. During the Carrington event, did the sun cause wires to ignite? No, wires did not ignite. During the Carrington event, what happened, and first of all, it wasn't the Carrington flare that caused anything. It was actually once the big solar storm that was associated with that event reached Earth, it rattled the Earth's magnetic shield to the point where the Earth's magnetic shield, as it rocked and rolled and is moving around, okay, bye, babe. As it was rocking and rolling and moving around, it induced into the ground currents. And most of the rock that we live on top of can conduct current to some degree. It doesn't conduct current very well. And so when you have transformers that are grounded, right, these big electrical wires that have these big systems that are grounded into the bedrock, when electricity or when potential sees that it has a path to get up into the electrical wires, obviously electrical wires conduct current a lot faster, a lot more easily. And electricity is always looking for the easiest path. So it will then, instead of having to force itself through rock over great distances, says, hey, I've got a superhighway here. Let me just jump into these wires. So it doesn't cause the wires to ignite. It actually induces the bedrock itself, basically dumps its charge into the electrical wires and makes the wires carry a massive current and have huge voltage drops across it, which isn't so bad for the wires other than heating them up. But it can cause issues, big issues for the systems that are carrying it. And back in the 1850s, when we had nothing but big transmission wires that were long and unbroken, that were used for telegraph, they weren't even power lines. They weren't designed to be used for what was happening to them, because people didn't understand about space weather. What would happen is that the telegraph machines that were connected to the telegraph wires, well, they were getting this huge current. And so their operators were trying to unplug them because they were sparking. And they would unplug them, and the dang things would still work because they were still being, given enough power to work. And they didn't care how the power was coming in as long as they were able to run. And yet it was too much power. So they would spark. And what would happen is that the sparks would catch the telegraph paper on fire. And that's how things caught on fire. It wasn't that the wires melted or anything like that. But we do have issues like that. There's lots of complications when it comes to power grids and transformers. But that's something that I talk about in my mini courses. So I'm not going to go into it too deeply here. But yeah, I just want to make sure I clarified that. Okay, awesome forecast. Sunspots are showing some promise to 2992 to leave off a huge solar flare on the back a couple days ago. Not on the far side a couple days ago, but on the west limb. Yes, it did. X flare, near X flare. It was like an M9 point. It was literally like a 989 or something. It was essentially an X flare. It was very, very high, and it also launched a solar storm, but it's not Earth directed. So, thank you, Maverick. I appreciate that. Earth is a sleazy hotel. Okay. Yes, but what does that have to do with space weather? Could that occur again in today's day and age? And if so, could it collapse the electric grid? No, it will not collapse the electric grid. Could it happen in today's day and age? Likely not. And the reason why is because we're a lot smarter. We're smarter in the sense that we no longer have hundreds and hundreds of miles of unbroken power lines like we did with telegraph lines. Remember, telegraph was made for communication, not for driving power. So it was a totally different system. We don't have that kind of system in place now for communications. So that's one thing. Number two, we are much smarter than we were even back in the 1980s when it comes to space weather events and what they can do. And really, the biggest thing that electric grids need to do is be able to ride out these storms without shutting down. That's how you keep power grids stable. And where we get into trouble is that a lot of the fail-safes in these power systems are designed to shut them down anytime there's anomalies. And really, strangely enough, it seems counterintuitive, but what has to happen when we have these big storms is that a lot of these fail-safes have to be shut off because the grid really does need to ride through it. And because of that, I think it's very savvy for us as just the public to know where a role that we can play when it comes to things, because I mean, all of us have experienced things like rolling blackouts, right? We all know what that's like, and for one reason or another. And in a solar storm, when there's a big load on our national power grids, the same kind of thing can happen. Is that we as the public can deal with either having to have rolling blackouts or reducing our power consumption so that these grids can ride out these storms and ride out these extra current loads much more readily than they would otherwise. I mean, they may think that we aren't a force, right? Like one little ant doesn't mean anything, but millions of us all together working in tandem, that really makes a difference to power grids. So I think we really can mobilize and help mitigate through even the worst of events. And that's one thing that these agencies don't factor in when it comes to space weather and how the public can help. So as long as we continue to raise awareness, then we can start making play an active role in mitigating, even the worst, even the Carrington class, so that we don't have to worry about, the Armageddon situation, the being blown out to the dark ages, all that kind of stuff. It just doesn't have to happen in our day and age. So hopefully that answers that question. Yeah, right. The price tag for rebuilding our grid is massive. We don't have to, but again, that's based on a catastrophic failure where the public isn't even helped, isn't even engaged to help. These grids don't have to fail. There are lots of ways to mitigate through that, and half of it is just being aware that there is a load on these grids. Let's see. Okay. I have to go, nice seeing you. Oh, that's cool. Mother Earth has a heartbeat. Yeah. Okay. How about questions? Let's see. Can an X-class blow out transformers though? No, these are flares. Solar flares can't blow out anything. It can, this is basically the sun screaming, right? What ends up impacting Earth is a solar storm, a coronal mass ejection that arrives at Earth, which is totally different than a solar flare. Don't conflate the two. They're totally different phenomena. Oftentimes they happen together, which is why people conflate the two. But a flare, you don't look at a coronal mass ejection and have it hit Earth and say, oh, it was an X-class. No, there's no X-class rating or M-class rating for a coronal mass ejection hitting Earth. And those are the things that cause geomagnetic storms. Those are the things that drive the currents. Those are the things that give us aurora. Flares do not. Flares cause radio blackouts. They cause radio bursts that then can drown out communications, satellite communications, or even ground and skywave communications for amateur radio operators, or even airlines. Okay, but those are different phenomena, and they only occur on the day side of Earth. These big geomagnetic storms, and especially the big currents that they can induce in the ground, oftentimes are most intense at night. So as you can see, there's even a day-night difference between the two phenomena. So don't worry about the X-class flares. Like I said, we don't even have a geomagnetic storm headed toward Earth. So X-class flares can't do anything when it comes to our power grids. It's a complete nothing burger in that sense. This is why I can be jovial when we see X flares. They're not planet killers. Sorry. I mean, well, what am I saying sorry for? You should be happy, right? Okay, do we have a CME on the way? No, we don't. We don't. Sorry, John, we don't have a CME on the way. It's a lot of fun to watch the paparazzi bulbs, right? But we don't have a CME on the way. I mean, as crazy as crazy as this looks, let me go back to, you know, as wonderful or as crazy as all this looks with all the pop, you know, there's nothing going on down here. We have nothing going on here at Earth. And it's just a lot of, it's you know, it's just a big Hollywood red carpet event, essentially. It's nothing more than that. So, you know, just enjoy the show from that perspective. Okay, let's see. There is a very long time on the new replacement transformer orders. Yes, of course. Increasing our manufacturing capacity. I'm sure we are, you know, to the best we can. I mean, I think right now COVID is a much higher problem for us than these storms. But there are people who are aware of it, and they do what they can. But like I said, that's why I think that the public does have a role to play. Don't feel that you are completely powerless in helping us ride out these big space weather events when they occur. But don't worry, there's no big space weather event on the way. Okay, an X50 could what? An X50 flare, if it occurred on the East Limb, is not going to send a coronal mass ejection our way, likely. Okay, if it is, we'll get the edge of it, and it probably will be a G1, a minor storm. As a matter of fact, that's what we had back in September 10th of 2017. Do you know that was a Carrington class event that hit us, but it clipped us? We had a big flare, an X82, if I recall. It was an X82, I think. The second largest flare, check. The second largest flare in our cycle 24 that happened on I might have been here, but it was on the west limb. It was actually occulted. It was actually happening behind the sun just a little bit, and it fired it that way. And yet the edge of that CME, that big solar storm, clipped us. Okay, and that was a Carrington or near Carrington class event, but it just clipped us, so we hardly noticed it. It was like a G1 level storm for about 3 or 6 hours. I can't remember. So these types of things happen all the time, guys. Okay, they're much more common than you might realize. And just because you see a big X class flare with the big X factor, please don't get anxious about it. Don't have anxiety. It's really not worth it. You're just fooling yourself. Okay, September 10th. Yeah, it was. That was a really scary. That was the one time, if you guys know me quite well, that was the one time that I wasn't joking. Because when that ugly thing, region 2673, I think was the region, and when that thing emerged on the Earth-facing disk, it was scary. And I was having lots of conversations with people, with scientists behind the scenes, and we were talking about this was one of the ugliest, if not the ugliest, sunspot region we had seen in all of cycle 24. We were very nervous about what it was going to do. And I was nervous in particular because I was worried about Irma and Harvey and all of the decimation in Puerto Rico and in Houston and in the Keys and all of that from those hurricanes, because they had nothing, and amateur radio operators couldn't do their job either. So it was a very tough time, to be honest. So somebody gives up, and I don't know why you give up. Maybe I didn't see a question that you had. Okay. So hopefully for the most part, people are, you guys are calmer, right? And you're not so freaked out with all the craziness that's going on YouTube right now. What can we do to get people like you on the nightly news? Well, I'm training meteorologists now to get on the nightly news. I'm training broadcast meteorologists. I have been on the Weather Channel. I've been on, multiple channels, and I do get requests quite a bit to come on the air. I got one just during these recent storms or these recent flares, and honestly, I'm slammed. I'm not able to do it. That's kind of why I'm training people, is so that there's going to be more than one of me. Thank goodness, because I can't be the only space weather person for the globe. Weather is just too there's just too many locales, and the space weather, just like terrestrial weather, affects people in different ways and affects different communities in different ways. And so we really do need space weather forecasting to be an extension of terrestrial meteorology. And I think we're going to get there. Hopefully during the solar cycle, we'll start seeing it a lot more often on the news. Yeah, and it won't be Chicken Little. It won't be Panic at the Disco, right? Panic in Detroit. It won't be that kind of stuff. My goodness, we don't need it. We need, we need everybody to be thumbs up about Aurora and happy about it, without thinking, oh my goodness, you're so evil, you want everybody to die. No, that's not true. Nobody does. Starlight says, thanks, Tamitha. Do you think enough time has passed with unexpectedly high SFI to start believing we're going to have a better than predicted solar cycle 25? Yes. Yes. Do I think it's going to be as high as the Macintosh, NCAR, UCAR crew thinks it's going to be? No, I don't think it's going to be 250 or, I don't think it's going to be a cycle 19, but I do think it's going to be, it's definitely more than the consensus. I think that's being borne out pretty well in the data when you look at it. Both sunspot number and solar flux, and then also, but I think it'll probably be closer to what the median for, if you look at all the cycles, cycle 1 through 24, if you look at how long they've lasted, I mean, how intense they are as an average, I think we're going to be right around there. So bigger than cycle 24, but definitely a lot less than cycle 19. It'll be nice though. It's because it also will get a lot of the grand solar minimum people to kind of quiet down and realize that, there's lots of variability in our star, and not every time that we see the sun kind of quiet down and go into these low cycles, does that mean that sunspots are going to turn off? It just doesn't mean that. There's so much more to how our star works than what we fully understand. So I'm confused. No Carrington type event possible except for a CME. Right, a Carrington class event is at least the part that worries Earth, okay, is a CME. It's just a very intense CME. It's the most intense of the intense. We get CMEs hitting Earth all the time, these coronal mass ejections. They hit Earth all the time, okay, and you'll hear me refer to them as solar storms. You'll hear me refer to them as CMEs. You'll hear me refer to them as ICMEs, because I just means the interplanetary counterpart of what we're looking at the sun when a CME launches, okay? But Carrington class is a class of CMEs. Now you can have a Carrington flare, because Carrington is a person, and he saw both the flare, and then we had a coronal mass ejection that hit Earth, right? That was launched with that flare. Okay, multiple types of space weather events happen simultaneously, which is why everybody thinks they're all a solar flare. No, we had a coronal mass ejection that was a very intense coronal mass ejection that was associated with the flare that Carrington witnessed. So it's called a Carrington event. Okay, the CME itself was just very, very strong. These X-class flares that we're seeing, they have been launching coronal mass ejections. Okay, so we have been seeing CMEs launched. None of them are Earth-directed. Okay, and trust me, none of them are even close to a Carrington class event. None of them. Okay, so we're all right. So hopefully that clarifies things. Okay, the only solar storm that we're going to be seeing coming to Earth in the next week is going to be from some fast solar wind. From this coronal hole. That's a coronal hole. Okay, it's not a real hole, just looks like a hole in this wavelength. This means fast solar wind is going to come at us, which is like if you're a boat plowing through a stream and you get that bow wave right in front of the boat, that bow wave is going to hit us, and that boat is the fast solar wind. And so that will splash over us, and that is kind of like what a coronal mass ejection feels like. It's not the same thing, not the same source, because there's nothing being ejected other than just fast solar wind, but you still get a similar kind of effect. It's just going to be weaker. So hopefully that clarifies that. Okay, guys, any other questions here? What's your take on micronova? Great for young stars, not for our middle-aged star that just, our middle-aged star is boring. It just kind of wants to work its way to retirement, get Medicare, send the kids to school, get enough funding so they can get off to college and be able to pay its debt and, and sleep. Read the newspaper in the morning, eat spaghetti at night and relax. Our star is a very boring star. Okay. Micronova is not in the cards for our star. So please stop, don't listen to Phil Plait. Don't listen to Neil deGrasse Tyson. Don't listen to people who are astronomers and love to talk about things like micronovas. And wouldn't it be great if our star did that? Wow, the Earth would be toast. Isn't that cool? No, it's not cool. You're scaring the poop out of people. Stop it. Our star is not going to do that. Okay. So, are you married? Yes. Thank you. I will take that as a compliment. Let's see. Do you have any comment on the 14th of April, where we only observed pulsating aurora for hours, even though we had very good negative BZ for hours? 14th of April. Do I remember the 14th of April where we had pulsating aurora? The nice thing about pulsating aurora is that as soon as you say that, what triggers in my head is that we're actually recovering. So we were recovering from something, obviously. Oftentimes you probably saw the what's called the subauroral arc, or often called Steve. That particular phenomena also happens during the recovery phase of a lot of these storms. I don't have any, I don't have a perfunctory response to that, simply because I can't remember off the top of my head, and I'd have to go take a look at solar wind data. And I don't have anything set up to do that right now. But if you're on Patreon, I forgot who asked me that. If you're on Patreon, ask me that on Patreon, and I'll dig into it. I promise. Because I always love looking at mysteries like that. If it's anything like the Starlink thing, where we had the preconditioning of the Earth's system was such that the magnetic field was reversed, and we had like a lot of northward field prior to the southward field, that kind of thing. Or if it were a quick turning from southward to northward or something like that, that kind of thing can oftentimes slow down and stymie certain activity for at least a few hours. So that may have played a role. I don't know. I'd have to look at it more intensely. Okay. Coronal hole solar winds not as fast as an X flare. Again, an X flare is a flare that's not a coronal mass ejection. X flares aren't fast, other because they don't have particles. They're light. It's light waves. They move at the speed of light. There's no pushing of particles. You're comparing apples and oranges. If you're talking about a coronal mass ejection that would be associated with an X flare, okay, then we can talk. And yes, typically coronal mass ejections that are associated with really eruptive flares, they are oftentimes very fast. So much faster than so you're talking about, let's say, the front of fast solar wind, which could be around, the fastest we know is around 800 kilometers a second. A solar storm that was, a CME that was launched during a big X-class flare could be over 1,000 kilometers a second. So yes, they're typically faster, even at the extremes. That's why CMEs are the ones that everybody's scared of. Most people don't even realize that fast solar wind can cause solar storms to occur. Okay. Hi, Tamitha. If something big happened, there's not a lot we could do about it anyway. Yeah, if something big happened, I mean, it all depends. And like I said, with power grids, we might be able to there is a role for us to play. Obviously, the safest things that you guys can think about doing is find out who has solar power in your house, in your house. Find out who has solar power in your neighborhood. Find out where your amateur radio operators are, because those are the kind of people that you want. You want to be able to have, if power does go out and it takes a little bit to get restored, you're going to want to know people who can generate their own power, and you want to know people who can who know how to do communications. Basically bouncing signals off of the ionosphere, because that really is kind of our ancient way of Wi-Fi, cell phone network communication prior to the advent of the technology that we have. So, or better yet, become an amateur radio operator, and then you can be a hub of communication for your neighborhood in case of something untoward happening. Okay. Oh, am I missing Lisa? Well, I'm seeing something funny, but I don't know who's saying it. Okay. Luckily, a lot of people have solar power here in Northern California. Smart. I'm so glad, Spirit. That's so awesome. It's savvy to have it if you can. And no, big solar storms will not take out your solar, your solar panels. Whether or not you'd have to try to figure out how to disconnect from the grid, I don't know. But that's something that you have to, that having the solar power is probably very smart if you're in an area on the planet that is conducive to that kind of thing. Okay, guys, I think let me check Patreon real fast to make sure nobody's asking me questions, and then I will probably say goodbye to you all. Thanks so much for all the really good questions. I hope that oh my goodness, I got a lot of comments here. I hope that the questions that I answered and the things that I said help you very much. Let's see. Spock's daughter, hopefully you got on. Hopefully. Okay. Good. You guys got it. Everybody looks like they're on. Okay, good. All right. No questions, just a lot of comments on Patreon. So that's wonderful. Okay, guys. That's excellent, Glade. I've got solar panels and battery backup for my ham radios. There you go. KJ7VZY. If you live anywhere near Glade, man, that'd be a person. Yeah, definitely good person to know. If there's a space weather incident, absolutely, or any kind of natural disaster. Amateur radio operators and preppers are awesome people to know, and most of them are incredibly savvy. So those are definitely good people to know, like I said. All right, guys, you take care. Oh, I had one more, but you think I answered. Okay. Can the Earth become overcharged and emit plasma everywhere? Well, overcharged it is on the day side, right? The sun is charging the Earth's atmosphere all the time. It's the ionosphere is plasma, and we have many layers of that plasma all over our planet. Air glow is another example. Right, a lot of people don't even realize that the Earth is emitting air glow all the time, both on the day and the night side. It's just you don't see it except on the night side. So from that perspective, yeah, it's doing it all the time. But the concept of overcharging, nah. I mean, the Earth will find a steady state, and the processes of both ionization and recombination, they always find their happy medium, and that process changes the higher up you go in altitude, which is why we have ionospheric layers. that process of recombination and ionization, where you form plasmas and then you kind of recombine, and you form plasmas and you recombine, that is a striated kind of process. And the chemistry, both the atmospheric chemistry and the molecular constituents, all of that changes, and the density and everything else changes as you go up. So if you're interested, yeah, definitely look at some atmospheric chemistry, but you can learn a lot about plasma and how it's formed and how the Earth deals with all that, and the space weather implications for that, and the neutral atmosphere implications for that. You can learn a lot about that by looking at ionospheric physics. So hopefully that answers that question. Thank you, Roger. I'm sorry you came in late. This video will stay up, though. I did a big forecast prior, early on, and now I've been doing a Q&A for about the last, I don't know, oh my goodness, half an hour. Okay. All right, guys. I believe I've answered all the questions. So, yeah. Okay, guys. Good. All right. I will say goodbye to you and have a good weekend. And don't worry about the sun. We're doing fine. And let's keep our fingers crossed that we will get some decent aurora from the fast solar wind, because I think these guys are all spent. Okay. All right. Talk to you soon.